Hello everyone. This video is on KnewtonAlta assignment, section 1.5, part 4, titled Factor Expressions with Fractional or Negative Exponents. Alright, the purpose of this video is to go through a version of the KnewtonAlta assignment. Please understand that the questions I'm going to be seeing in this video may not be exactly the same questions you see when you work on the assignment yourself. Alright, but they should be similar enough and the objectives are the same, so that hopefully watching me go through these here will help you in some way when you're doing it yourself. Alright, so here's your assignment page. Again, you won't see the word preview, you'll just see the title. You have your mastery bar telling you how far along you've gotten. You can see the objectives. Looks like there are only 2 objectives in this assignment. And then beneath is a question on the current objective. Right, so this question here is on factor expressions using fractional or negative exponents. Then at the bottom of every question, you should see a couple buttons. There's the feedback button, where you can, if you see like a typo or something wrong with the question or the answer, you can send feedback to Newton and they'll address it, hopefully. You will not see this instructor cheat button, right? This is only for me. But you will see the more instruction button, right? Which is very important. If you are struggling with a particular objective, you don't remember how to do things, or a particular question, don't just guess an answer and get it wrong, because if you get things wrong, your progress bar will go backwards and then you'll have to do more questions to complete the assignment. So if you're ever struggling with something, try this out. Click on more instruction. It'll take you to either some reading or videos, and then some questions related to those reading and videos, and hopefully you can get through the assignment that way. And you can do more instruction for every question if you wish and get through the assignment in its entirety. Nothing wrong with that. Okay, so let's get started here. The first question. Again, it's on factor expressions using fractional or negative exponents. So we're seeing this expression here, negative 8 times x times the quantity negative 5x plus 1 to the 3/5 power, right, a fractional power, minus 7 times the quantity negative 5x plus 1 to the 8/5 power, another fractional power. So I'll write this out and talk about factoring it. So again, the expression we're given, negative 8x times the quantity negative 5x plus 1 to the 3/5 power minus 7 times the same, negative 5x plus 1 quantity to the 8/5 power. All right. So when they talk about factoring here, they're talking about pulling out the greatest common factor. Remember that GCF, which you have seen earlier in some section 1.5 assignments. Well, this time though, with these fractional powers, and the same thing goes for the negative powers, right? This whole objective is on fraction powers, negative powers. Just pull out the common factor. They both have, see this negative 5x plus 1 as a factor to the lowest power, right? If this was cubed into the 8th, you'd say cubed was the greatest common factor, right? They have at least 3. So you pull it out to the lowest. So you pull out common factors in each term raised to the lowest power. So here I'm going to pull out, this negative 5x plus 1 to the 3/5 and 8/5. The smaller of these two is 3/5. Now be careful. If this was negative 3/5 and negative 8/5, then negative 8/5 would be smaller. Remember the number line, and how negative numbers compare to each other. All right, so I do that. So I pull the greatest common factor out. Now, if you want, you could also pull out a negative sign, because the lead term here. Well, technically this would be the lead term because it has the highest power, has a negative number in front of it. You could pull out a negative, but I'm not going to do that here. Just because all they're really asking us to do here is pull out the greatest common factor with these fractional powers. All right, so if I remove this, if I remove 5x plus 1 to the 3, negative 5x plus 1 to the 3/5, that'll be gone from here, and you'll have negative 8x in that first term of the next factor. And we have minus, and then 7 times. Now be careful. When you pull out the greatest common factor, you got to think, oh, what's left over? If I were to redistribute negative 5x plus 1 to the 3/5, how do I get the original expression back? So, 3/5 plus 5/5 would be 8/5. Right, remember when you multiply things with the common base? Right, when you multiply things with the common base, the powers get added. Right? Hopefully that makes sense or sounds familiar. So negative 5x plus 1 to the 3/5 times negative 5x plus 1 to the 5/5 would be to the 8/5, right? 3/5 plus 5/5 is 8/5, but that's just the first power. Right? 5/5 is 1. 1 plus 3/5 is 8/5. Great. Then we simplify the expression in here. Now I have expressions to whole number powers, so I should be able to multiply this out and simplify it. All right, so we have a negative 7 to distribute. All right, this is just negative 5x plus 1 to the first, so I don't really need the first power there. And we have this negative 7 to distribute. And then we combine like terms. So we have the GCF pulled out, right? Negative 5x plus 1 to the 3/5 times, and then here we have negative 8x plus 35x. All right, negative 7 times negative 5x. So 35x minus 8x would be 27x, positive 27x. And then negative 7 times positive 1 would be negative 7. And there's your second factor after pulling out the greatest common factor of negative 5x plus 1 to the 3/5. And this is what they want us to do, right? Factor, rewrite as a product. Right. And if you want to check, all you need to do is go backwards, right? This could be rewritten this way, and then if you redistribute, you'll get the original expression back. Right. So if you wanted to check your work, just kind of work backwards, make sure each step going backwards is valid, makes sense, is equivalent. Alright, so back on the assignment page, that's what I shall type. So we have negative 5x plus 1 to the 3/5 power. Sorry, that's tiny there. Times. Right, times, and then 27x minus 7 for the other factor. And that should be good. Look at that. Right. Okay, and again, please, read through the answer explanations, whether you're right or wrong. Because if you're right, read through them to make sure you got it right for the right reasons, that you didn't just get lucky, that you understand what's happening. Or, they may even go over a different way of doing something that you didn't think of that you like better and might want to try in the future. And if you got it wrong, definitely read through the answer explanations, figure out why you were wrong or where you went wrong, and try to fix it in the future. Alright, so moving on. Alright, now the next question is switching objectives here, is on factor expressions using greatest common factor and other technique or other techniques. So basically, all the techniques we've seen in this chapter, right, or this section 1.5, all the part 1, part 2, and part 3 assignments, those techniques are coming back. You have to remember all of them, all right, and use them when they're applicable. Right? They're not always going to all be used, but whenever they do apply, you have to recognize that. All right, so we're asked to factor the following polynomial completely. So I'll write this out on paper. So we have a 10x squared minus 490. The first step is always factor out the greatest common factor. That is always the first step in factoring. So the greatest common factor here of these two terms is 10. I hope you see that. They both have 10 as a common factor. If I factor out a 10, then what's left over is x squared minus 49. Okay, so yes, this is factored, but not completely. Right, because now numbers you're going to leave alone. I know you can factor 10 further to 2 times 5, but any numerical factors you're going to leave alone. Right, and I'll make that little note. Leave numerical factors as they are. Right, I'll just say leave numerical factors. It's the other ones with the variables, right? The factors of the variables that you got to check. So this is factored, but not completely. Right? They did ask us to factor completely. And it's not factored completely because this x squared minus 49 factor can be factored further, right? This is actually one of those difference of squares. And I'm not going to go into all the formulas and whatnot and all the methods from parts 1, 2, and 3 of section 1.5. I'm just going to assume you remember them. This is x squared minus 7 squared. So this should factor to x minus 7 times x plus 7. And you can check that by multiplying. Or x plus 7 times x minus 7. It doesn't matter what order you put the factors in. And this is it. This is factored completely. Right. Again, leave numerical factors alone. X minus any linear factors, unless there's a greatest common factor to pull out, but that should be the first thing you do. Linear factors should be as factored as possible. And sometimes there are quadratics that you can't factor any further either, right? Like x squared plus 1. Right? If this was x squared plus 49, then we would stop. There is no sum of squares. You can't factor a sum of squares, only a difference of squares. But this is factored completely. All right, so this is what I'm going to enter in my assignment. All right, so back here we got 10 times the quantity. X minus 7 is another factor, and then times x plus 7. All right. And submit, and hooray, we got it right. And again, please read through the answer explanations. And let's move on. Alright, so this is the very same objective. Now again, they're not always going to be two terms, right? I mean, if I get through this assignment in this video and I see only this kind of problem, please know that there are other problems they're going to have where there's trinomials or things with 4 terms that you might have to factor by grouping. So, review those methods, those factoring techniques from the first 3 parts of section 1.5, please. Alright, so once again, I'll write this out. We're asked to factor it completely. I'll just do it on the same page here. So we're given 9x squared minus 81. And again, GCF is 9. I'll pull out 9 first. And then what's left over would be x squared minus 9, right? 9 times 9 is 81. So it's factored, but just like the previous problem, not factored completely. X squared minus 9 is x squared minus 3 squared. It's a difference of squares. So this will factor to 9 times and then x minus 3 times x plus 3. There's your different x squared minus 9 factored. And none of those factor any further. Again, leave the numerical factors alone. I know 9 can factor to 3 times 3, but leave it alone for these problems. All right. So going back here and entering those factors. 9 times x minus 3 times x plus 3. And submit. Great. Alright, and again read through the answer explanations. Let's move on to the next question. Alright, so now we're back to that objective factoring expressions with fractional or negative exponents. So again, let me just write this one out for you. Alright, so the expression we're given here, negative x times the quantity 3x minus 5 to the negative 4/5 power, and then plus 2 times the same thing, the quantity 3x minus 5 to the 1/5 power. Right. Sorry, let me get actually on the screen. Now both of these have 3x minus 5 to some power in common. So take 3x minus 5 to some power. The lowest of those powers is negative 4/5, right? I know you're probably thinking, hey, 4/5 is bigger than 1/5, but it's negative. So this is lower. All right, this is considered smaller. So we pull that out. I'm going to pull out 3x minus 5 to the negative 4/5. And then the factor remaining, what's remaining? Well, that's all removed from the first factor, so I'm just left with negative x. Then we have plus 2 times, and then negative 4/5 plus 5/5 again would be 1/5, right? Negative 4/5 plus 1 would be 1/5, and that, so I need 3x minus 5 to the first in there, right? 3x minus 5 to the negative 4/5 times 3x minus 5 to the first 5/5 would be 3x minus 5 to the 1/5. That would give me the original expression. All right, and then once again we got to simplify in here, distribute this 2. So we have 3x minus 5 to the negative 4/5 outside times, and then negative x plus 6x would be 5x. And then, 2 times negative 5 is negative 10. All right. And they didn't say factor it completely. All right. It just says factor the following expression. Because if I needed to factor it completely, I would then have to do this one. 5x minus 10 has a common factor of 5. I'd factor out a 5 and put a 5 out in front and have x minus 2 here. But they did not ask us to factor completely. They just said factor it, and this is factored. The original expression rewritten as an equivalent product. And again, if you go backwards, it all fits. Right? This is equivalent to the original. All right, so that's what I'll enter. So we have the 3x minus 5 raised to the negative 4/5 power. Make sure that's all in the power there. Then come down and write the other factor, which was 5x minus 10. All right. And submit. Looks good. All right, again, please read through the answer explanations. All right, next question. And back to that other objective using the factoring techniques, and here we go. We got a trinomial. Good. And so I'll write this one out. Right, so we are given 4x squared minus 16x plus 16. Again, the first step in any factoring is the greatest common factor. Pull it out, which would be 4. Pull out 4. And if I remove a factor of 4, then we have x squared minus 4x plus 4. Right, and now I have to factor this, right, x squared minus 4x plus 4, and this is one of them trinomials, a quadratic trinomial with a lead coefficient of 1, right? That's 1x squared in here. So all I need to do is find the factors of 4 that add up to negative 4, and that would be negative 2 and negative 2. So this is 4 times x minus 2 times x minus 2 again. Well, look, if something factors to the same factor twice, that means it's a perfect square. So this is an example of one of those perfect square trinomials. Which you can again go over in one of the earlier parts of section 1.5. Because it's the same factor twice, and if it's the same factor twice, usually you don't write the factor twice, you write it as a square. So this would be 4 times, and then the quantity x minus 2 to the second power. This is how I'm going to type it in. Right? And again, if you want to verify it, square this, you get x squared minus 4x plus 4 back, and then you distribute the 4, you get the original. Right? You check by multiplying. Okay, so we have 4 times the quantity x minus 2 to the second power. And that should be good. Submit. Excellent. And again, please read through the answer explanations. Hopefully those make sense. Next question. Alright, so we're back in the same objective. Alright, so I'm just going to write this one up. Let's do it on the same paper. So here we're given 4x squared minus 16x, but this time minus 20. Once again, the greatest common factor is 4. Right, all three terms have the coefficients that are a multiple of 4. So 4 comes out times x squared minus 4x minus 5. Alright, and then once again I have a quadratic trinomial with a lead coefficient of 1. Right, it's 1x squared in here. So all I need to do now is try to find factors of negative 5, the constant, that add up to negative 4, the linear coefficient. That would be negative 5 and positive 1. And when the lead coefficient is 1, you very simply just write, x with one of those, right? X with one of those factors, x minus 5, times x with the other one, x plus 1. Right? Negative 5 plus 1 is negative 4, and negative 5 times 1 is negative 5. And there you go. That's factored completely. All right, now please understand, the question, I saw 4 questions here. This objective is going to be over. You might see some other quadratic trinomials where the lead coefficient's not 1, so you got to factor using the grouping method. You go back to part 1 of section 1.5. Just please refresh your memory on all the factoring techniques from parts 1, 2, and 3 of section 1.5. Alright, so 4 is one factor times, and then it was x minus 5 times x plus 1, or x plus 1 times x minus 5. It doesn't matter what order you put those in. Great, and that should be it for that objective. Alright, then the last questions are on the other objective, right, with the fractional and negative exponents. Right, so again, I shall write this out, and we'll factor it the same way I've done all those other ones, right? Those other 2 examples from this objective from earlier. So here we're given 7x times the quantity negative 7x plus 1 to the negative 2/3 power minus 2 times the quantity negative 7x plus 1 to the positive 1/3 power. Right? So they both have this negative 7x plus 1 to a power. The lowest of those powers is negative 2/3. So that's what's coming out. So I factor out negative 7x plus 1 to the negative 2/3 times, and then the what's left over, well, in this first term here, just 7x. and then you got minus 2 times, and then negative 7x plus 1 again to some power, so that when I take negative 2/3 and add the powers, I get 1/3. Well, negative 2/3 plus 3/3 would be 1/3. So this is the first power here. And then we got to simplify this in here. Distribute the negative 2. So this is negative 7x plus 1 to the negative 2/3 power times, and then 7x plus 14x would be 21x. So there's 21x in this second factor. And then negative 2 times positive 1 would be negative 2. And there you go. Here's the original expression factored, right? Written as a product. And that's what I'll type. So we have the quantity negative 7x plus 1 raised to the negative 2/3 power. Get down, and then times 21x minus 2. And that should be good. Hooray. And then I should have one final one. And as long as you're not getting things wrong, usually it'll be like 4 questions per objective. Alright, and then the very same thing here. Alright, so once again I'll write this out, and we'll take a look at factoring it. So negative 6x times the quantity, negative x plus 7 raised to the negative 4/5 power, then minus 7 times negative x plus 7 to the 1/5 power. And this is pretty similar to the second example we did in this objective earlier with the negative 4/5 and the 1/5 power. They both have this negative x plus 7 in common. So I factor out negative x plus 7 to the lowest power. The lowest power on these is negative 4/5 times what? All right. Now the first term, the first product, would have negative 6x left over. Then we have minus 7. And then, negative 4/5 plus 5/5 is 1/5, just like earlier. So I need negative x plus 7 to the 5/5 in here, which would just be negative x plus 7 to the first. Now I distribute this negative 7, and we simplify that second factor. So we have the GCF, negative x plus 7 to the negative 4/5 times, and then negative 6x plus 7x after distributing would be 1x. And then negative 7 times positive 7 would be negative 49. And that's how simplified the second factor gets. And there you go. There's our original expression factored, right? Rewritten as a product. So we have here quantity negative x plus 7 raised to the negative 4/5 power. And get out of there, come down. And then the other factor was x minus 49. Wonderful. And this should be good. Alright, great. And again, please read through your answer explanations, whether you're right or wrong. And that should be it for this version of this assignment. As I said at the top of the video, please understand that the questions I saw here may not be exactly the same questions you see when you're doing the assignment yourself, but they should be similar. The objectives don't change. You'll still see the same objectives. So I'm hoping that watching me go over at least these 8 examples here help you in some way when you're working on the assignment yourself. And thank you very much for watching.